There are varying philosophies among contractors regarding the salvage of old material during commercial demolition or remodel projects. Firstly, there is the preserve and reuse approach. The benefits are that it reduces waste and promotes sustainability, maintains the historical integrity of the building, and can save costs by reusing existing materials that are still in good condition. Considerations for this approach include the need for careful dismantling and proper storage to prevent damage, and it may not be possible if materials are damaged or are outdated to current codes. Secondly, there is the remove and discard approach. The benefits are that it simplifies the demolition process and minimizes potential hazards, eliminates the need for storage and handling of old materials, and ensures that only compliant and up-to-date materials are used. Considerations for this approach include increased waste and disposal costs, and it may require additional materials and labor to replace old components. Thirdly, there is the partial salvage approach. The benefits are that it combines aspects of both approaches by reusing some valuable materials while discarding less desirable ones, and reduces waste and preservation costs. Considerations include the need for careful assessment and selection of materials to salvage, and it may still require additional materials and labor for replacements. Regarding specific practices for salvaging conduit, most contractors will save larger diameter conduits, for example 3-inch and above, due to their value and reusability. Smaller conduits, for example 1/2 inch, are typically discarded due to their low cost and abundance. Conduit with visible damage or deformation should be discarded for safety reasons. Conduit that does not meet current electrical codes or safety standards should not be reused. The benefits of salvaging conduit include cost savings. Reusing conduit can reduce material and labor costs. There is sustainability, which conserves resources and reduces waste. It can also maintain historical preservation, which maintains the original character of the building. Saved conduit can be convenient and easily accessed for repairs or upgrades. Considerations for salvaging conduit include storage space, where adequate storage space is required to prevent damage or loss. Also, consider the time and labor. Extra time and labor may be needed to properly salvage and store conduit. The compatibility must be determined. Saved conduit must be confirmed to be compatible with the new electrical system. Safety is paramount, and ensure that salvaged conduit is in good condition and meets current safety standards. The 2014 National Electrical Code, or NEC, as with subsequent versions, provides guidelines for the installation and use of electrical equipment and materials, including conduit. While the NEC doesn't explicitly dictate whether or not old conduit can be reused, it does set standards for the condition and suitability of all electrical components. When considering reusing conduit, several NEC articles are relevant. Article 110.3 B covers examination, identification, installation, and use of equipment. It states that equipment must be installed and used in accordance with the instructions included in a listing or labeling. This means any reused conduit must be suitable for its intended purpose and installed correctly. Article 300.12 addresses mechanical continuity, electrical continuity, and grounding of raceways and cables. This section is crucial because reused conduit must maintain its mechanical and electrical integrity. It should be free from damage that could compromise its ability to protect conductors or serve as an effective ground path. Article 314.16 covers the number and size of conductors allowed in boxes and conduit bodies. If reusing conduit, ensure that the number and size of conductors you plan to install are within the fill limits specified in this article. Overfilling conduit can lead to overheating and insulation damage. Article 344 pertains specifically to rigid metal conduit, or RMC. If you're reusing RMC, ensure it's still in good condition, with no significant corrosion or damage. Threads must be clean and undamaged to ensure proper connections. Article 352 covers rigid polyvinyl chloride conduit, or PVC. If reusing PVC conduit, check for cracks, brittleness, or degradation from sunlight exposure. PVC conduit can become brittle over time, especially when exposed to ultraviolet or UV light. Article 356 addresses liquid tight flexible metal conduit or LFMC. If considering reusing LFMC, inspect it carefully for damage to the flexible jacket and ensure that fittings are properly installed and provide a liquid tight seal. Any breaches in the jacket can compromise its integrity. Article 250 contains the requirements for grounding and bonding. Reused conduit must be properly grounded and bonded to ensure a safe and effective ground fault path. This is crucial for protecting against electrical shock hazards. Article 300.4 deals with protection against physical damage. Ensure that reused conduit is adequately protected from physical damage during and after installation. This may involve using straps, supports, or other protective measures. In summary, while the NEC doesn't prohibit the reuse of conduit, it emphasizes that all electrical equipment and materials must be in good condition, suitable for their intended use, and installed according to the code. Always inspect reused conduit thoroughly and ensure that it meets all applicable requirements before using it in a new installation. If there is any doubt about its condition or suitability, it's best to err on the side of caution and use new conduit. The decision to save old material, particularly conduit, from demolition or remodeling jobs is multifaceted, especially in commercial settings. It involves weighing factors such as cost, time, sustainability, safety, and code compliance. The value of large diameter conduits, typically 3 inches or greater, often justifies the effort to salvage them. These larger conduits represent a significant material cost, and their reuse can lead to substantial savings. The labor involved in carefully removing, cleaning, and storing these conduits is often less than the cost of purchasing new materials. The condition of the conduit is paramount. It must be free from significant damage, corrosion, or deformation. If the conduit shows signs of wear that could compromise its structural integrity or ability to protect conductors, it should be discarded. Compatibility with the existing or planned electrical system is crucial. The type of conduit, its dimensions, and its fittings must match the requirements of the project. Mixing different types of conduit or using incompatible fittings can lead to unsafe conditions and code violations. The National Electrical Code, or NEC, provides guidelines for the proper installation and use of electrical materials. While it doesn't explicitly prohibit the reuse of conduit, it mandates that all electrical components must be in good working condition and suitable for their intended purpose. Reused conduit must meet all applicable NEC requirements, including those related to grounding, bonding, and conductor fill. The available storage space and the associated cost play a significant role in the decision to save old conduit. Adequate storage is needed to protect the conduit from damage and deterioration. If storage space is limited or expensive, the cost savings from reusing conduit may be offset by the storage expenses. The time and labor required to salvage, clean, inspect, and store old conduit must be factored into the economic equation. If these activities consume too much time or require specialized labor, the overall cost-effectiveness of reuse may be diminished. Sustainability considerations are becoming increasingly important in the construction industry. Reusing old conduit reduces waste and conserves resources, aligning with sustainable building practices. This can enhance a contractor's reputation and contribute to projects seeking green building certifications. Safety must be the top priority. Old conduit should be thoroughly inspected for any signs of damage or deterioration that could pose a safety hazard. Any conduit that is not in excellent condition should be discarded to prevent potential electrical problems or injuries. The current electrical codes and standards must be adhered to. If the old conduit does not meet current code requirements, it cannot be reused. Code compliance ensures that the electrical system is safe and reliable. The potential liability associated with reusing old conduit should be considered. If the reused conduit fails or causes a safety issue, the contractor could be held liable. Thorough inspection and testing can help mitigate this risk. In summary, the decision to save old conduit from commercial demolition or remodeling jobs depends on a careful assessment of various factors, including cost, condition, compatibility, storage, labor, sustainability, safety, and code compliance. While reusing conduit can offer cost savings and environmental benefits, it must be done responsibly and in accordance with established standards and regulations. Small diameter conduits, such as those that are 1/2 inch or 3/4 of an inch, are often discarded due to their relatively low cost and the availability of new materials. The labor involved in salvaging, cleaning, and inspecting these smaller conduits may not be economically justifiable. Damaged conduit, regardless of its size, should always be discarded. Conduit with visible damage, such as dents, cracks, or corrosion, may not provide adequate protection for electrical conductors and could pose a safety hazard. Outdated conduit that does not meet current electrical code should not be reused. Electrical codes are updated periodically to reflect new safety standards and technological advancements. Using outdated conduit could result in code violations and compromise the safety of the electrical system. The benefits of salvaging conduit can include cost savings by reducing the need to purchase new materials. This can be especially significant for large projects that require a substantial amount of conduit. Sustainability is also a key benefit. Reusing conduit reduces waste and conserves natural resources, contributing to more sustainable construction practices. Historical preservation is maintained when reusing conduit. It can help preserve the original character of older buildings, which may be important for historical or aesthetic reasons. Conduit that has been saved can be readily available for repairs or modifications to the electrical system, reducing downtime and improving efficiency. However, there are considerations. Adequate storage space is essential to prevent damage and deterioration. Conduit should be stored in a dry, protected environment to maintain its condition. The labor costs associated with salvaging, cleaning, inspecting, and storing conduit must be considered. If these costs are too high, it may not be economically feasible to reuse the conduit. The compatibility of the old conduit with the existing or planned electrical system is crucial. The conduit must be compatible in terms of size, material, and fittings to ensure a safe and reliable electrical system. The safety of the electrical system and the people who use it must be the top priority. All salvage conduit should be thoroughly inspected and tested to ensure that it meets current safety standards. The 2014 National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations, including the use of conduit. Some key sections of the NEC that are relevant to the reuse of conduit include Article 110.3 covering examination, identification, installation, and use of equipment. This section requires that all electrical equipment, including conduit, be installed and used in accordance with the manufacturer's instructions and any applicable listing or labeling requirements. Article 300.12 covers mechanical continuity, electrical continuity, and grounding of raceways and cables. This section requires that all raceways, including conduit, be installed in a manner that ensures mechanical and electrical continuity throughout the system. It also requires that raceways be properly grounded to provide a safe path for fault currents. Article 314.16 covers number of conductors in outlet, device, and junction boxes, and conduit bodies. This section specifies the maximum number of conductors that can be installed in a given size of conduit. When reusing conduit, it is important to ensure that the conduit is not overfilled, as this can lead to overheating and other problems. Article 344 covers rigid metal conduit, or RMC. This section provides requirements for the installation of RMC, including requirements for supports, bends, and fittings. When reusing RMC, it is important to ensure that the conduit is in good condition and that all fittings are properly tightened. Article 352 covers rigid polyvinyl chloride conduit, or PVC. This section provides requirements for the installation of PVC conduit, including requirements for supports, expansion fittings, and burial depth. When reusing PVC conduit, it is important to ensure that the conduit is not cracked or damaged and that it is properly supported. The decision to save old material when removing it from a commercial demolition or remodeling job requires careful consideration of several factors. Firstly, consider the type of material. Is it conduit, wiring, fixtures, or other electrical components? The value and potential for reuse will vary depending on the material type. Secondly, assess the condition of the material. Is it damaged, corroded, or otherwise compromised? Only materials in good condition should be considered for salvage. Thirdly, determine code compliance. Does the material meet current electrical codes and standards? Using non-compliant materials can create safety hazards and legal liabilities. Fourthly, evaluate the cost-effectiveness. Is it economically viable to salvage, clean, and store the material compared to purchasing new materials? Fifthly, consider the environmental impact. Reusing materials reduces waste and conserves resources, aligning with sustainable practices. Sixthly, assess storage availability. Do you have adequate space to store the salvaged materials properly? Seventhly, determine labor requirements. Do you have the personnel and expertise to safely remove, handle, and inspect the materials? Regarding conduits specifically, large diameter conduits, typically 3 inches or greater, are often worth saving due to their higher material cost. Smaller diameter conduits, such as 1/2 inch or 3/4 of an inch, may not be worth the effort unless they are in exceptional condition. Rigid metal conduit, or RMC, offers good protection for conductors and can be reused if it is not damaged or corroded. Intermediate metal conduit, or IMC, is lighter than RMC but still provides good protection. It can be reused if it meets code requirements. Electrical metallic tubing, or IMD, is a lightweight option that is easy to install. It can be reused in dry locations if it is in good condition. Flexible metal conduit, or FMC, is used for connections to motors and other equipment. It should be inspected carefully for damage before being reused. Rigid polyvinyl chloride conduit, or PVC, is corrosion resistant and suitable for underground or wet locations. It can be reused if it is not cracked or brittle. Liquid-tight flexible metal conduit, or LFMC, is used in wet locations or where flexibility is needed. It should be inspected for damage to the outer jacket before being reused. The benefits of saving old materials include cost savings by reducing the need to purchase new materials, resource conservation by reducing waste and conserving natural resources, reduce landfill waste by diverting materials from landfills, historical preservation by preserving the original character of older buildings. The considerations include storage space by requiring adequate space to store salvaged materials properly, labor costs by requiring time and effort to remove, clean, inspect, and store materials, code compliance by ensuring that salvaged materials meet current electrical codes and standards, liability risks by potentially increasing liability if salvaged materials fail or cause safety hazards, environmental impact by potentially offsetting environmental benefits if the salvage process consumes excessive energy or resources. The best practices for saving old materials include developing a salvage plan before starting the demolition or remodeling project, identifying materials that are worth saving and designating a storage area, safely removing materials without causing damage, cleaning and inspecting materials to ensure they are in good condition, verifying that materials meet current electrical codes and standards, storing materials properly to prevent damage or deterioration, documenting the salvage process to track costs and benefits. In conclusion, the decision to save old material from commercial demolition or remodeling jobs depends on a careful assessment of various factors. While reusing materials can offer cost savings and environmental benefits, it is important to prioritize safety and code compliance.